Hello and welcome back to another episode of Sparky's Tech Corner. Now we're back again at the Yamaha DSP today. I went ahead and put the board back into the unit and I went to go troubleshoot it and see what would happen. And I'm going to go ahead and move this camera down to in front of the unit. I'm gonna freehand it so it's going to move around and all the other good stuff, so please bear with me. The reason why I want to freehand this is because, like I said, this stereo unit, if you can just see it, it's huge and heavy. I can barely fit it on my desk. But if I go freehand and try to power it on again, you see it does the same thing again. Powers on for about 2 or 3 seconds and then goes out. However, I go through here and I actually put a voltmeter on it. And I've got a chip pin pulled out right here. And that's pin 8 of that CPU. If I just go through here and I put that little clip on pin 8. And jump through here and I'll try this again. I've also got an issue with the LCD. There we go. Let's do that again. Power it on. I said the LCD is going out of it, but it's doing a lot better than what I was doing beforehand. It's actually staying on now. And I've actually located, this tells me a lot now, because I've actually found that pin on schematic and I've got it kind of flowed out where I need it. So I'm going to go ahead and throw a schematic up and I'll show you exactly what I'm looking at. So pretty much how I figured this out is on this schematic, if you look down at pin 8, which is PO5/AN5, and you go down to the description, pin 8, port AN5, name PR. Let's see, yeah, PO5. I don't know why it's named that way, but the function of it is AD DC protection. This circuit actually tells the CPU if it needs to go into protect mode or not. Now, if we look at this schematic right here, we'll see CB11IC1, which is the CPU, and again we're going to go to pin 8. That is PRD or PRO. It's kind of hard to read because this is a scan schematic. If you follow that up, you'll see that pin 8 will go to a pull-up resistor, 100k ohm resistor, and that is R10. And that switch actually goes up to power switch 2. And that is actually what dictates the CPU whether to turn the system completely on or to turn it off. So, knowing that, if you follow the schematic around, I'm just going to show you where it goes at the end point. It goes to this little ribbon connector, CB1. That goes to A4 on the main board. And see, that's pin 2, PRD. So, if you follow that to this right here is N4 on this socket. N4, we have a lateral line diode system with capacitor, and that circles back around. That goes to a junction block right here on the bottom 4-pin rows, and then that circles back around to this. If you look on the line that has the going straight up and down, right in here, it's got that 82k ohm or 534. That is actually the line that goes up back to PRD. That is actually the PRD line. So, if you look at that, all these little pull-up resistors. And this is the idling current channel. This circuit actually tells the CPU if there's voltage on the circuit or not. So, with that, I know of a couple different places I need to look now, just because of fighting this. However, it is remarkable that I was able to stumble upon this, because that tells me now there's this main amplifier board on the bottom that I've got some circuit protection going on in it, or there's a couple diodes and resistors on this board that could theoretically cause the same thing. Although now, instead of saying on the DC PRD, I believe. Give me 1 second. Yeah, DC PRT. Beforehand, before I reflowed the entire board, it was saying DC PRT 0%. Now it's saying 36%. So there was something up with this board, but that's not all it's wrong with it. So what we're going to do now is we're going to go ahead and finish disassembling this entire unit, getting to the main board down here, and then going through and seeing if we can't find out what our problem is. So with that, let's go ahead and get set up to get this thing to apart. Before we tear this thing apart, I'm going to check this 100k resistor. It's right here, and it's a small resistor, so we're just going to go ahead and check it real quick. 100.1. Okay, so I know that this resistor is okay. So the only other place that where this goes is out of the board to the main amplifier. So let's go ahead and get turned down, and hopefully this will be not as complicated as the Onkyo was. I'm hoping I just pull this whole board assembly out. I may not be able to. I might have to take this back plane off. We'll see what happens. So, like in every one of my other videos, enjoy the music while this is being fast forwarded for you. while I tear this apart. And that pretty much does it for the teardown. Now, I had to cut these wires, and I really didn't want to. But there's no way to actually get these wires out. So I'm going to do one of two things. Either I'm going to resolder them in together, or I'm going to put connectors on them. That way, if the board ever needs to be tore apart again, you can easily just undo a connector and redo a connector. I might end up doing that. But for the most part, it's out. And what I'm going to do now is I'm actually going to go ahead and test these two capacitors. And let's see here. Now all these wires connect together regardless anyways, so it doesn't really matter on which way I put these wires back together, but I want to go ahead and do that just so they be in the same place as what they were. So I'm going to go ahead and test these two capacitors real quick. the 27,000 microfarad capacitor, and that is a pretty seriously big capacitor. That's 17,000 bigger than what was in the Onkyo. So we're dealing with some pretty big power on this. Ground. And of course, my meter cannot read it. Let's try again. Okay, this one's only reading 6,000. That one's reading higher. But regardless, it's not what it needs to be. So again, just like on anything else, I guess we're going to go ahead and replace these capacitors as well. Just because they're not at what they're supposed to be at. Oh, hang on a minute. Oh, never mind. Okay. These are 4-pin capacitors. So, B negative, B is 20,000 microfarads, negative, negative, black. A and C are blank. That's an interesting little capacitor. Alright, so that really tells me I need to get I need to get a new meter that will actually read up that high. Because 20,000 megafarads is my max. So even if this one was good, I couldn't read it anyways. Just the fact that it's only reading 6,000, that tells me that we probably need to replace capacitors. So next video we're going to be going over the amplifier board. Let me get this. We're going to be going over this board in the next video. That'll be part 5 of this series. This is part 4. And I guess we'll go ahead and get some capacitors ordered to replace these, since they're looking a little low. 47, 47. Let's go ahead and check these two real quick as well, just to make sure. .79, that's good. And that one's off. So we got 4 capacitors to replace, the 2 main ones and the 2 sub ones. Just because this one's bad and this one isn't, doesn't mean I'm not gonna replace this one. This one's getting replaced. Just because Because when you get one capacitor goes out, you get another one that goes out. So this is the main rectifying board for this transformer. So yes, we're just gotta go ahead and replace capacitors. That way we've got nice clean power going to the rest of the system. So that'll be another episode to this too, is replacing both capacitors. And that does it for this video. Like always, like and subscribe, and I'll see you guys on the next one. Thank you.